So hello everybody, and thank you for attending this first summer, not summer school, but autumn school of MoleculArXiv. So we are pleased to receive you in Cargèse for the first time for MoleculArXiv for this program. So I'm Marc Antonini, so I am the program director of MoleculArXiv, and I have 15 minutes, I guess, for presenting you rapidly the project that I am managing. So, and the first question that probably you have is, what is MoleculArXiv? So, MoleculArXiv is a French research program that was launched in 2022. The idea of, maybe I should, I don't know if I, oops, I cannot remove what is upstairs, no? No, but the mouse is disappearing, but no, I cannot. Oh, okay.
Is it appearing from your computer or from the computer that?
Probably. Let me check. Okay. Let me check again. Yeah, it was a problem of maybe on my computer. Right? It was my computer probably, and I should. No, but no, anyway, I cannot, I guess. Yeah, it's okay. Good, nice. So, okay, so MoleculArXiv is a research program that aims to develop molecular-based data storage and also processing. So, we want to do...
You're not sharing on Zoom.
Oh, yeah, sorry. I am the cobaye, the first. Let me check now. Oops, documents. Stopped. Is it good now?
Yeah.
Okay, so good. I can start again. So. So MoleculArXiv is a program which aims to do molecular data storage. So we are addressing both DNA polymers and non-DNA polymers, so synthetic polymers. And we gather several labs in France with some activity on chemistry, biology, physics, and computer science. So it's a very large spectrum of activity. And currently the program involves 80 researchers in 27 laboratories. So we have a budget of 20 million euro over 9 years and a half. So the CNRS is the leader of this program. And ANR, the French agency, is acting as an operator. So what are the objectives of MoleculArXiv? So as you know, the data is growing a lot today on the Earth, and you are here, I'm sure, because you are aware about that. And as you know, probably it will reach 175 zettabytes in 2025, and I guess it was 181, the new forecast. So we have some problem for storing this quantity of data. So the idea of MoleculArXiv and what MoleculArXiv was designed, was conceived, it's for developing a solution for being able one day to store such quantity of data. And as you know, the idea of MoleculArXiv is storing data on molecules, on DNA, and as you know, writing and reading molecules, it's not very fast. And one of the issues, if you want to store data on DNA, is the speed, the writing speed compared to a hard disk drive or even tape. And so our main goal in this project is to accelerate the writing speed and, of course, the reading speed. And today, as you know, for writing 1 unique bit, it's around 100 seconds. And so the idea here is to be able to accelerate from a factor of 100 before the end of the project, the writing of 1 unique bit. and the idea is to go to writing one unique bit in 1 second. So this is a big challenge, but we hope that we will be able to do that, and also thanks to parallelization, we will be able to reach high speed, I hope 1 megabit per second. And the idea at the end of the project is to write with our partners 10 gigabytes of data in 1 day with off-the-shelf parallelization. So MoleculArXiv, at the beginning, it was a 4 targeted project. So 1, 2, 3, and 4. So it's TP1, TP2, and TP3 and 4. The first one is next generation DNA synthesis, and the idea is to develop new or advanced DNA synthesis method for accelerating the writing speed. The second project, targeted project 2, from digital data to synthetic DNA. So it's the goal is to develop technology for converting bits. Bit stream into a quaternary code adapted to synthetic DNA storage. And also we are working on the sequencing of this data to be able to read back the information. And then the third targeted project is new polymers and alternatives. So it's a very prospective project, and the goal is to create new digital polymers. The idea is to be able to store more than four nucleotides, so to have a storage capacity or a writing power above what we can do with DNA. And then the final project is project 4, making DNA storage a practical reality. So the idea here is to develop a demonstrator and proof of concept with some of our partners, which are the INA, in France, Institut National de l'Audiovisuel. We have the European Parliament also as partner, and we have Software Heritage. Okay, so in 2025, 3 projects joined MoleculArXiv because we launched a call for a call in 2024, and 3 projects have been selected by an international committee. And so we have the first associated project, optical sequencing of digital polymer. So it's to develop optical sequencing method for non-DNA polymers. The second project is peptide storage of information using spin correlation. So it's enabling the storage of information within peptide-based polymers. So these 2 projects are more related to the targeted project 3, which address non-DNA polymers. And the third project, which is very important for us, it's a high-density DNA writing platform based on CMOS technology. So the idea here is to develop a CMOS a chip that allows to parallelize the synthesis process. So, which is very important because we have we will use new technologies and new chemistry for doing synthesis, and chemists are working on unique bit writing, and we have to be able, we must be able to parallelize this on electronic chips to accelerate the process. So as you know, just reminding you some of the basic steps of DNA storage. So we have the binary information, the conversion to a quaternary code, which is not obvious, as you know probably, because we have to respect some constraints. Then once you have the DNA code, you can write it on molecules. So this is a DNA synthesis. And then we can store it inside capsules or microcapsules. And then you can do the decoding by reading back this information. So it's sequencing. And then after reading back the code and correcting errors, and we will see during this school several talks about error correction and processing of DNA after sequencing. Once we clean the data and correct the errors, we are able to decode perfectly, or almost perfectly, the binary file that we have as input. So in this project, we have targeted project two which work on encoding and decoding, and also participate to the storage. All the targeted project participate to storage and here. But we have TP2 for encoding and reading. We have TP1, 3, and new projects, associated project 1, 2, and 3, that contribute to the DNA synthesis and also to the storage activity. And that's it. So we are covering all the different steps of this cycle. The technical roadmap, and the roadmap in general. So as you know probably now, we have international workshop and international school. So last year we organized a workshop. It was in Nice, in France. This year, this is first autumn school, and we want to that this each 2 years to reorganize workshop, and each 2 years to reorganize schools, so summer, autumn, or winter schools. Next year there will be a new workshop, an international one, that will be organized in Rennes. So maybe some of the people or the organizer are here, and maybe they can talk about that later during the school. So just for the technical roadmap, we have several milestones, let's say, and what we want to do is in 25 we have the synthesis of a short message with a new technology, with a speed which is called to the state-of-the-art speed. In 27 we want to accelerate by a factor of 10 the state-of-the-art, writing at 0.1 bit per second, and in 29 the objective is to synthesize long message at 1 bit per second, so 100 times state-of-the-art. So this is thanks to development of the chemistry, and the goal in 2031 is to parallel, thanks to have a parallel synthesis, so to parallelize the chemistry, and thanks to a CMOS chip, which is the goal of one of the associated projects, and to be able to write, we hope, 10 gigabytes of data per day, and in April 32, to have a full cycle of cold storage, and a demonstration of full cycle of cold storage, and also with our partners, so the 3 partners that I told you. So the key advancements, so we have 3 technical platforms, one at Gulliver on high throughput evolution of polymerase. So we have one platform at Institut Pasteur for synthesis of oligonucleotides with non-canonical building blocks. And we have also UCA Genomics at University Côte d'Azur, which is a genomic platform for doing the sequencing. So what we did since the beginning, so it's not exhaustive, but it's some of our activity. So we organize a workshop in May 24. We have a strong link with our end users, Institut National de l'Audiovisuel, European Parliament, Software Heritage. We launch in 25 DNA data storage working group with one of the group de recherche in France. It's specific to French activity in research. So it's a GDR IASIS for some of you who know that. Okay, we organized, and we are organizing the autumn school in Cargèse. We are participating in the autumn school. And we are working on the organization of a second international workshop to be held in Rennes. Then we relation with industry, so we create a MoleculArXiv working group focused on transfer and innovation. And the goal is to see how we can do a transfer of our technology, maybe a patented technology or collaboration with companies. And international outreach, we are participating, and I think that most of you know the DNA Data Storage Alliance. We are also working on standardization efforts, and especially on JPEG, and we are working on the, some of you are working on the, are working on the JPEG DNA standard, which will be released next year, in 26, end of 26, which will allow the storage of, will standardize the storage of images and molecules. And we are also working towards a flagship project with Europe. So what are the objectives and the role of MoleculArXiv in shaping the future? So futuristic vision, let's say, of today, it's DNA as ultra-dense and sustainable digital storage integrating into everyday technology. We can have active molecular computing one day with search, retrieval, and storage processing. We hope that we can have shoebox-sized data center and to be able to store with less environmental impact. And also we aim to have random access DNA read and write. So in that context, MoleculArXiv will contribute by building scalable and affordable DNA synthesis and sequencing system, which is very important today, because if we are not able to read and write fast, DNA will not be used for any application in DNA storage. We are also doing some innovation in molecular encoding, compression, error correction, etc. That's in the full process of the DNA writing. Developing microfluidic and for high throughput molecular data access and driving IP strategy and standardization to enable broad adoption. And of course, we are doing it's prospective, but we can have some innovation and technology that then can be transferred to or patented or also pushed in the industry. And we are also trying to see how we can do that. So bridging today and tomorrow. So we think that MoleculArXiv is one of the actors that lays the foundation for these transformative futures. And you are participating today to this school, and we hope that we will, for most of you probably, learn several things, new things around the DNA data storage, hoping to involve in the future more people in this research area. So thank you for your attention, and I just want to take this opportunity to pay a tribute to Anthony Genot, who was one of the leaders of the MoleculArXiv project, and also he made the success of this project. So he was a brilliant researcher, and he left us too soon. So thank you. If you have any questions.